This video is on ER. ER, or Entity Relationship Model, is a conceptual model that is used for formalizing data requirements between the business user and the information architect. It's an easy-to-understand graphical representation of the data requirements that is user-friendly, simple as that. ER model is made up of 3 building blocks, which are entity types, attribute types, and relationship types. Entity types simply represent a collection of similar things and are represented in rectangle in a ER model. Each of these entity types have attribute types that describes the entity types, like name, addresses, and social security numbers, and are represented in ellipses. Then we have relationship types, which are association between one or more entities like student and course, or student and teacher entity types that are represented in rhombuses. Entity type student with student ID, student name, and student age as its attribute types will have multiple entities. Entity type is pretty much a general term that is used to define collection of entities that have similar characteristics, while entities are individual items that exist. The details of individual entities are attributes and are categorized by attribute types. For example, age is an attribute type, while the actual age of a person or entity, 21, is an attribute to an entity. Attributes usually have a specified domain, but in the case of ER model, it is not shown, which is one of the downside of ER model. For example, attribute type color can be set to be either black or white, which means it is specified to have 2 values. There are many different attribute types in the ER model, like key attribute types, simple and composite attribute types, single-valued and multi-valued attribute types, and derived attribute types. Key attribute type is something that is unique, like a social security number or student identification number, because it doesn't repeat in the database and can be used to identify individual entities in a unique way. Height of a person or weight of a person isn't a key attribute since it could potentially repeat, and it cannot uniquely identify each entity. In the ER model, key attribute types are underlined. If the entity types don't have a key attribute type, it is considered a weak entity type. If it has key attribute type, then it is a strong entity type. Weak entity type will borrow an attribute type from a strong entity type and will refer it to as owner entity type. Weak entity types are represented with 2 rectangles, and a weak entity has what's called partial key, and it is used to uniquely identify a weak entity for a given owner entity. Then we have simple or atomic attribute type, which means it is an attribute type that cannot be further divided. And then we have composite attribute type, which means it can be divided into more attribute types. For example, address attribute type can be broken into street number, zip code, and country attribute types. So address is the composite, and individual attribute types that got derived from that is simple attribute types, like the zip code, because it cannot be broken down anymore. Name is another composite attribute type that can be broken down into 3 simple or atomic attribute type, like first name, middle name, and last name. Then we have single-valued attribute type, which means there can be only one value for that entity. For example, social security number is a single-valued attribute type since you cannot have more than one social security number. Multi-valued attribute types, on the other hand, means you can have more than one value, like email addresses or phone numbers, because technically an entity can have more than one email addresses or phone numbers. In the ER model, multi-valued attribute types are depicted with double ellipses. Then we have derived attribute types, which are basically attribute type that can be derived from another attribute type. For example, age attribute type can be derived from date of birth attribute type. Derived attribute types are depicted using dashed ellipses in the ER model. Now we talked about the entity types and the attribute types. Let's go over the last building block of the ER model, the relationship type, in more detail. Relationship type basically defines association for one or more entity types. Relationship types are depicted using rhombus symbol, and they can be seen as 2 arrows put together. Relationship types are based on degree or number of entity types participating in it. Relationships are based on degree. Degree is basically the number of entity types participating in the relationship. So if there's only one entity involved in the relationship, it's called unary. If there's two, then it's binary. If there's three, there's ternary relationship. And then we have roles. Roles of the relationship basically indicates the direction of the arrow and are used to describe in more detail on the relationship. For example, relationship type between buyer entity type and seller entity type is binary since two entity types are involved. And the roles are buying and selling. Another example is entity type employee. Let's make this unary since there's only one entity type involved in the relationship. How does this work? Well, employees include supervisor and regular employees, with roles supervisors and supervised by. Next, we have cardinalities. Cardinalities in relationship represents relationship instances that entity can participate in and has minimum and maximum number with colon between it. Minimum is either 0 or 1, and maximum is either 1 or n. If minimum is 0, it's basically stating that the entity can exist without being connected to another entity, which means it's partial participation since not all entities may not participate in the relationship. For example, entity person and entity school. Not all person will be attending school. If the minimum is 1, then it's stating that it must always be connected to some entity and is considered total participation or existence dependency, since that entity needs to depend on the existence of another entity. For example, entity student cannot exist without entity school. When it comes to maximum, 1 means that entity can be involved with at most one entity, while n means it can be any integers bigger than 1. Let's take a look at this example. Employee can work in minimum of one department and maximum of one department, and department can have minimum of 0 employee and maximum of n employees. Here, employee entity type depends on department because they need minimum of 1 and the maximum is 1, and the department entity can exist without the employee because it doesn't need a single employee for it to exist. Just like entity types, relationship types can also have attribute types as well. In the case of M-N relationship, attribute type needs to be specified as a relationship attribute type. 1-1 or 1-N can be moved around to participating entity types as needed. Let's go over unary, binary, and ternary relationship examples and talk about ER limitations. Here's a unary relationship. We got the entity type employee with the attribute types employee ID that is underlined, which means it's a unique attribute. And then we have employee name, employee address, and employee salary. Employee address is a composite attribute and it can be broken down. Same thing applies to employee name. It can be broken down into first name, middle name, last name, and so on. Employee has a relationship within itself. We have the supervises and supervised by, treated as two arrows pointing at the entity. So one arrow is pointing at employee and it has supervised by. Follow the arrow and it will show you minimum cardinality of 0 and maximum cardinality of 1. So employee can be supervised by minimum of 0 and maximum of 1 employee. Basically, it's saying you have maximum of 1 supervisor. And the CEO don't really need a supervisor. And then we have the other arrow that goes supervises from the employee with the minimum cardinality of 0 and maximum cardinality of n. It basically says an employee can supervise minimum of 0 employee and maximum of n employees. Let's take a look at the binary relationship between employee and the department here. In this one, we don't have the minimum cardinality. It only shows the maximum cardinality because that's the usual case for ER diagrams. It shows the maximum cardinality. So employee with all those attributes and department with those attributes with name and number being key attributes and number of employees being a derived attribute because it is dashed ellipsis, and location attribute being multi-valued attribute because department can be located in multiple locations. So employee can work at maximum of 1 department and department can have maximum of n employees. It also has manages relationship between it. So employee manages a department and department is managed by 1 employee with the maximum cardinality of 1 each. And the rhombus of the relationship also has its own attribute, start date. Let's talk about ternary relationships. It could be displayed in two different ways by modeling it as binary relationship types or ternary relationship types. The goal here is to ensure semantics are not lost from making multiple binary relationships. As you could see here, we got 3 binary relationships on the top. We could literally combine that into a single ternary relationship. And the semantics is going to be lost at the top compared to the bottom. So at the top, we got the supplier and a buyer. Supplier Bob might have a buyer named Joe, but the products that buyer buys and supplier supplies isn't shown here. The next one, product and buyer, doesn't show who the supplier is for that product. And the next binary relationship, it doesn't show who the buyer is. It just shows the supplier and the product. So there's a lot of semantics lost here. This is why we have ternary relationship at the bottom. We have supplier, product, and the buyer. You know who the supplier is, what they're supplying, and who the buyer is. Here's an example. We have 3 entity types, instructor, course, and book. And we have the relationship rhombus in the center, use. Instructor has the attributes name as its unique key attribute type, and rank and qualification attribute types. And then we have course entity types with course number being the key attribute type with credits and names attribute type. And the book has ISBN number as its key attribute type with title and author attribute types. It's great to create a ternary relationship for these 3 entity types because you want to know what book to use for a specific instructor as well as know what course that the instructor can teach. Alright, let's talk about some of the limitations to ER model. First, we have the domains not shown that we talked about before. Some attribute types have certain domains. It could be a gender attribute type that could be either male or female, but you cannot show that domain in the ER model. Then we have temporal. Temporal constraints are time-based constraints. For example, attribute type address could be time-based because certain people have to move out certain times. Then we have consistency across multiple relationship types. There are some rules that cannot be enforced in the ER model, like certain employees cannot work in a specific department, or cannot work in a department that he or she manages. And finally, it does not support definition of functions, meaning any functions to calculate certain things in the attribute types, like calculating employee salaries, cannot be depicted.